Hello, everyone. This week we'll be beginning sections 11.6, 11.8, and so on. And especially in 11.6, a topic that becomes increasingly important is factorials. So this video is just about factorials. For those of you who haven't worked with them much before, just some introduction and then how we work with them. Okay. So this has been a topic I've noticed people struggled with in the past, which is why I wanted to do a little separate video on it. Okay. So let's first look at the definition of factorials. Okay. So n factorial, we denote it n with the exclamation point. What is that? It's when we multiply n by n minus 1, by n minus 2, and so on, all the way down to 3, 2, and 1. Okay. So as you may be able to tell, the factorial is only defined for integers. Okay? So only for positive integers, so natural numbers, really. Okay. So this isn't going to work with -3 or 7.6 or anything like that. It's only for these natural numbers, these positive integers. Okay. So one example would be 5 factorial. That'd be 5 times 4 times 3 times 2 times 1, which should equal 120. Okay. So this definition of factorials shouldn't be too bad. What I think gives people the most problem is simplifying factorials, especially fractions involving factorials. And we'll see how factorials cancel when I have maybe one factorial divided by another. Okay. So let's see that first, that most simple example of a fraction involving factorials. What would n factorial over n plus 1 factorial be? Okay. So since n plus 1 is in parentheses, what does that mean? That means on the bottom, I'm starting with n plus 1, and then I'm multiplying down. So in the denominator, I have this. I have n plus 1 times n minus 1, so on, down to 2 and 1. And then what do I have on the numerator? I have n factorial. So we know what that is. That's n minus 1, n minus 2, and so on, again, down to 1. Now, there's a lot of cancellation we can do in this fraction, okay? And in fact, we see that the numerator and the denominator are pretty much the exact same, except the numerator has this one extra term. So all these terms cancel. This n cancels, this n minus 1 cancels, so on. This is going to cancel, and then everything should cancel, except this n plus 1 here. So our simplified fraction would be 1 over n plus 1. So we're going to have to do this a lot with our series. We're going to have series with some factorials in there, and maybe some of the tests we do are going to involve these types of fractions. So we got to be prepared to do this kind of algebra. We can make it slightly more complicated. What if I had the fraction, let's say, I had this fraction here, n plus 5 factorial over n factorial. Let's try and simplify this. Okay, so take a second to do it on your own, and then let's see, if you want to do it on your own, go ahead and pause it. I'll write it out. All right, let's see the answer now. Grand reveal. Okay, so I've just expanded my factorials, and what do I have? On the top, I have n plus 5 factorial, so I got n plus 5 times n plus 4, and so on. And on the bottom, I have n times n minus 1, and so on. So what cancels? Let's see. My n's going to cancel, so that's my first term that cancels, and then all my other terms less than n are going to cancel, right? N minus 1 is going to cancel with n minus 1, and so on, all the way down to 1. So what am I going to be left with? I'm just going to be left with n plus 5. So I'm going to be left with this, n plus 5 times n times 4 times n plus 3 times n plus 2 times n plus 1. And in general, if I have a fraction of factorials, the smaller factorial should be canceled completely. And what's going to be left over is just everything bigger than that smaller term, okay? So the n on the bottom, the n factorial is going to cancel completely. And what am I going to be left with on top? Just everything that's bigger than n. So n plus 1, n plus 2, n plus 3, n plus 4, n plus 5. Now let's see some slightly more complicated examples. How about something like 3n factorial over 3 times n plus 1 factorial. Okay, so now I got a couple things going on. Inside the factorial, I have 3 times n plus 1. So it might help to first expand the stuff inside the factorial. Okay, and now let's try and simplify this fraction. Again, if you want to work at that on your own, pause it, and my answer will be up in a split second. Okay, so let's see, what do I have on the top? I got 3n, then 3n minus 1, and so on all the way down to 1. On the denominator, in the denominator, I have something very similar, but I have these extra terms. I got 3n plus 1, 3n plus 2, 3n plus 3. So like in the previous case, let's see, this time I have my smaller factorials on the top, but the same rule applies. My smaller factorial is going to be completely canceled. Okay, so all that stuff in the denominator is going to cancel. And it's going to cancel on the bottom too, right? I got 3n, and then I got a bunch of terms in between here. And then I got 1. All these terms cancel. And what am I left with? I'm left with 1 over 3n plus 3, 3n plus 2, 3n plus 1. And that would be my simplified fraction. So that's pretty much it for factorials, the algebra of factorials. It's not too complicated, but I know a lot of people haven't done a lot of extensive work with these, and it's definitely something we're going to need for 11.6. It's especially the ratio test, and even in later sections, it becomes very important to be able to work with these factorials. So give that a try and let me know if you have any questions.